Right, so I'm going to start where I stopped, and I believe was probably here. So here you want to see if there's a proportional relationship. Well, over here, just again, remember what I said. You definitely have to identify your y and x, okay, your input and output. So think about what happens first, and as a result, this happens as a consequence. Um, so, and in this case, let's see here, this is my x and this is my y, right, miles. So if we were to do k equals y over x for each of them, we would get 12 divided by 2, which is k equals 6. 20 divided by 5, k equals 5. K equals 7. I can even stop over here. K equals 6. So definitely this is not proportional. So if I were to graph that, okay, it would not be a straight line. Okay. Sorry. It would not be proportional. What it looks like, I actually don't know. It might be... it definitely starts at 0, 0, but it's not proportional. So it might be something like that. It might be. Whereas this one is definitely proportional, because if you do y over x, right, it'd be 18 divided by 3, k equals 6. K equals 6 over here, k equals 6 over here. So definitely a straight line. I'm curious to find out. Maybe I'll put that Monday and we can graph it. Okay, just to see what it looks like. But definitely this one is a straight line. Okay. If you where does x on each graph, and what does y represent? Well, you can always create a box, right? So we noticed that we knew that this was x and this was y. So let's create another box and put a 1 here. So in 1 hour, how much does he ride? So we know that the relationship was 6, so definitely 6 miles. Whereas here, I can't really tell. Okay, so if I create another box, in 1 hour, how many miles did he go? Well, it's not consistent, so he's going faster, going slower, going faster, going slower, so I'm not too sure how far he goes in 1 mile. Whereas this Dave is more consistent riding. Every hour he goes 6 miles. Okay, and 1 mile, which is right here, by my x value. So where x equals 1 on each graph, where does the y value represent? So it really represents 6. Graph below shows how many sodas employees a certain company consume each day. Okay, so is there a constant rate proportionality? Yes, there is. Well, it starts at 0, 0. Yes. Okay, starts at 0, 0, right? And it's a straight line. So what is the constant rate proportionality? Well, let me pick a point. I'm going to pick this point. Well, this one works. And that point is 140, right? X is 1, Y is 40. So I can use that. I can use that, and you can obviously already tell that's going to be 40, but it's y over x, which is 40 over 1, which is 40, which makes, if I turn this to unit rate, right, it means that they drink 40 sodas, right, because 40 represents 40 sodas in 1 day. So that's your unit rate, right? So we didn't have to do this. You just have to look at 1 and see the corresponding value for y, which was 40, so that would have been your unit rate. But fill in the missing quantity for the other pair, 1 and, so actually 1 and 40, we just did that. Okay. What is the other pair telling you? That in 1 day, the employees in that company, in that particular company, they drink a total of 40 sodas. Not one person, but all of them combined. What's the point 1.5 and 60 represent? Well, it represents that in 1.5 days, right? So think about the context of the story. So 1.5 would be 1.5 days, right? Comma, 60 sodas. So 1.5 days, which is about this here, 1.5, you go up, matches to 60. So this is your point 1.560. What does it represent? Well, it represents 1.5 days and a consumption of 60 sodas. Okay, hopefully Based on the understanding, the constant proportionality unit, how many sodas will be consumed after 5 days? Well, so you can, you know the relationship right here. 1 day, they drink 40, sorry. So your unit rate is what? So if you're doing that last question, you want to find out how many they drink in 5 days. Well, what's your unit rate? Your unit rate is 40 sodas in 1 day. That's how much they consume, right? So if you can create a proportional portion and find out, well, in 5 days, how much they drink, well, that's easy. Times 5. Times 5, you get 200 soda. That's a lot of soda. Oh, sugar. Okay. And we move on. In the Olympics, an Olympic runner had the following distances. What is the constant proportionality? Okay, again, who's your X and who's your Y? So this is your X, minutes, and Y. So you have several points over here, right? So pick a point. Let's just, well, guys, your unit rate, it's always going to be when it's 1, right? So let's take that point. If I were to get that point, it'd be 1 minute, 1,500. Right? So this is my X value. This is my Y value. So if I actually were to do this, it would be 1,500 over 1, which is 1,500. So my constant of proportionality is 1,500. If I change that to unit rate, maybe 1,500, 1,500, what do you call, feet in 1 minute. And it was already here for us. So we didn't really have to do that, but we did it. So what is the constant of proportionality? 1,500. Explain what this constant proportionality means in relation to the question. Well, in relation to the question, it means that every minute this particular runner, he travels 1,500 feet. What does the 0.2 3,000 represent? Well, 0.2 3,000 represent that in 2 minutes he ran 3,000 feet. A company selling something. The ratio here is P to R, right? So 20 peanuts over 50 raisins. 20p over, so that's your relationship. Where's the constant proportionality? So this, okay, wait. Not this pen. Let's delete this. Oh, it doesn't delete. Oh my god. Okay. Why it doesn't delete? Okay, now it deletes. So, I would call that the raisins, because so you're putting peanuts in this with raisins. So the P happens first and the raisins happens later. So to me, would be my X, and the raisins would be my Y. So that's what I would do. So after 10 placements, there were 20 peanuts and 50 raisins, so 20, 50. So if I were to find the constant proportionality, K equals Y over X, K equals 20, no, Y, which is 50 over 20, and K would be 2.5. Right? That kind of makes sense, right? Because the ratio is 2.5 bigger. The amount of raisins is 2.5 bigger. Okay. Yeah, that's it. 8, an American Idol is holding auditions, but they start auditions at 8 a.m. or 7 a.m. by 8 a.m. So it's always nice if I can create a table from this information. So starts at 7 a.m. So by 8 a.m. they had 35 people. So after 1 hour, So this is my hour. These are my people. So in 1 hour, 35 people came. By 9 a.m., which is 2 hours after you started, you had 70. By 11 a.m., which is 4 hours after you started, you had 140. So that's my table. What is the constant proportionality? Pick any of these points, and obviously you can already pick the one that has a 1 at the bottom, which is your unit rate. Your unit rate is 35 people per hour. And if you know your unit rate, you know your K, and the K is 35. But if you wanted to do it, K equals Y over X, and you picked this one, for example, and that would be 2 comma 70, right? Your X value, your Y value, and you would put 70 divided by 2, and you would get 35. So the constant proportionality is 35. If this wasn't a graph, explain what you believe the 0.6280 would mean. Well, it means that in 6 hours, 280 people were auditioned. High school band, blah, blah, blah. Is there a constant proportionality? Yes, there is. Yes, there is, because it starts at 0, 0. In this case, it's a straight line. What is it? Well, at 1, look for 1. So at 1 ticket was $10, right? So your constant proportionality is the same thing as your unit rate. Your unit rate will always be when X equals 1. So my X value, my Y value. So the unit rate is $10 for 1 ticket, right? Which is Y and then X at the bottom, 1 ticket. If you wanted to do K equals YX, just double check. Y equals 10, X equals 1, and you see that the constant proportionality is 10. And then if you change it to unit rate, ta-da, it becomes 10 over 1. Okay, so we answered that question. I'm not going to erase that. We're filling the missing quantity, the order pair 1. Well, order pair 1 matches with 10, so 1 ticket is $10. What is this order pairing telling you? Oh, I keep answering the future already. Well, 1 ticket is $10. What does the point 330 represent? Well, 3 tickets cost a total of $30. How many tickets will be sold at $100? Well, how many tickets will be sold for $100? Well, this one is not that difficult. You can definitely set your proportion, so you can use your unit rate. 10 tickets. I mean, I know this question is simple, but use your unit rate and set it up a proportion. And over here, you write 100, and you can definitely find a relationship times 10 times 10. So that gets you 10 tickets. Okay. Heartbeats of a parrot. What is the constant proportionality? Well, if I look at 1, I can't really tell because this is not, I don't know what value that is, so I can't use that easy tactic to find out the constant proportionality, because the constant proportionality would be this number right here. So let's pick a number we can actually see. About 4 and 600. 4 and 600 looks okay. This point right here. So K equals Y over X. K equals 600 over 4. And K equals what does K equals? 300, 150? That doesn't seem right. That's 100. Yeah, right, looks okay. K equals 150. So what's the constant proportionality? 150. So this value right there would be 150, which is 150. So what's the unit rate? The unit rate is 150 beats per 1 minute. Is that it? I'm going to erase that. What does this constant proportionality mean? Okay, it means that take that and we change that to unit rate. It means 150 beats per 1 minute. How much would it beat after 6 minutes? Well, we can use our unit rate, right? And just keep that. And over here, I'm going to write 6 minutes at the bottom. Times 6, times 6. I have no idea what that is. It looks like 900 beats in 6 minutes. Okay. And we have one more question. Okay, so anytime you have a table, let me just write X and Y here, and you have a value for 1, that's pretty much your unit rate. Okay, that's pretty much your unit rate. Based on the information on the table, what is the price per ton of steel? Well, I just showed it to you, right? It's $400 per 1 ton of steel, and that's our unit rate right there. You can tell this is a proportional table because it's times 400, times 400, times 400, times 400. So K would be 400, just in case they asked you. Website. So again, we got some time things. So anytime we have that, we can create a table, okay, just to see it better. Website records the number of hits after 12 p.m. So at 1 p.m., so I'm going to write hits, I'll write hour. 1 hour, they had 150 hits. At 2 p.m., which is 2 hours later, they had 300, and so forth. So you can clearly tell this is, what is a constant proportionality? Well, constant proportionality is your unit rate, right? So K would actually be 150, right? Which you can change to a unit rate. But I want to show you that if you picked another point, let's say this one, hour 3, 450 hits, right? So this will be the point on your graph. This is your x value, this is your y value, and if you use k equals yx, you get 450 divided by 3, and that would give you 150. So k is 150, which you can change to now a unit rate, which is 150 hits per 1 minute, which is exactly what we have here. So you can explain all that in your answer, that the constant proportionality is 150. And if you took this point, it would also be 150. And if you took that other point, it would also be 150. And therefore, it shows that it's a proportional table. Okay. And that's it. I think that's it.